This is section 2.2, graphs of linear equations, and we're going to do some selected evens from this section. So let's go ahead and start with question number 2. Question number 2 says, find the x and y intercept of each equation's graph. The x and y intercept, that's where it crosses the x-axis. Alright, think about it on a Cartesian coordinate system. So where it crosses the x-axis, that's the x-intercept. And where a line crosses the y-axis, it's the y-intercept. In order to find this, what you simply do is you let the y value be 0 to figure out what your x-intercept would be. And so you have, well, 2x is equal to 12, divide both sides by 2, x is equal to 6. So when y is equal to 0, x is 6. So 6, 0 is called the x-intercept. Now to find the y-intercept, you simply let the x be 0. So 2 times 0 plus 3y is equal to 12, and you solve for y. So 3y is equal to 12, divide both sides by 3, y is equal to 4. So our y-intercept, when x is 0, y is 4. So our x-intercept 6, 0, and our y-intercept 0, 4. Let's move on to question number 4. Question number 4, we're supposed to find the x and y-intercept as well. So to find the y-intercept, or to find the x-intercept, you simply let the y be 0. Alright, and solve for x. So all that's 0 right there, so that equals negative 12, divided by 3. So x is equal to negative 4. So my x-intercept is negative 4, 0. Now to find the y-intercept, you let the x be 0, and then solve for y. So this gives me negative 6y is equal to negative 12. Divide both sides by negative 6, and I get y is equal to 2. So when x is 0, y is 2. So my x-intercept is negative 4, 0, and my y-intercept is 0, 2. Let's move on to question number 6. Question number 6, the instructions say write each equation in function notation, then state the slope and y-intercept. So in order to find the slope and y-intercept, we put it in this form called slope-intercept form, which is simply y equals mx plus b. We solve for y, where m is your slope, and b is what we call the y-intercept, where it crosses the y-axis. Alright, so if we need to do this, we need to solve for y. So we get y is equal to negative 3x plus 5. Now it said put it in function notation, which just simply means replace your y variable with f of x, function notation. So there it is in function notation. And then your slope is the number in front of x, so it's negative 3. And your y-intercept, alright, your b value is 5. So your y-intercept is 0, 5. It's a point where it crosses the y-axis. So there's our function notation, there is our slope, and there is our y-intercept. Let's now move to question number 8. Question number 8 says state the slope and y-intercept of each equation. So again, I'm thinking of my slope-intercept form. This is most valuable. Y equals mx plus b. So let's solve for y. Get y by itself. Get 2y is equal to negative x plus 1. Divide everything by 2, each term, or both sides. So y is equal to, that's negative 1/2 x plus 1/2. Alright, so my slope is negative 1/2, and my y-intercept, my b value is 1/2, so it is 0, 1/2, where it crosses the y-axis. So there is my slope and y-intercept. Moving on to question number 10. Number 10, I'm supposed to state the slope and y-intercept. So again, I'm thinking y equals mx plus b. So I need to solve this for y. So subtract x from both sides. I get negative 3y is equal to negative 2x plus 6. divide everything by negative 3. This gives me y is equal to, and negative divided by negative is a positive, so it's 2/3 x, and 6 divided by negative 3 is negative 2. So there it's in slope-intercept form, so my slope is the number in front of x, 2/3. My y-intercept is that number out there, so it's 0, negative 2. So here is my slope and my y-intercept for question number 10. Moving on to question number 11, or excuse me, number 12 and 14, we have two lines graphed here, and I'm supposed to find the slope of each graphed line. Now, in order to find the slope, I need 2 points. So I don't have 2 points as an ordered pair, but I can look at my graph and I can see for number 12 that there's a point right there, and that is negative 4, 0. And I also see a point right there, that is negative 2, 1. Now you could use your change in y's, y2 minus y1, over your change in x's, x2 minus x1, or whenever I simply have a graph, a picture, I just count, because slope is equal to rise over run. So I'm going to rise 1 and run 2. So my slope here is 1/2, 1 over 2. Now when I look at line D, I notice it's a vertical line. So think of slopes as when you're skiing on a ski slope. If you're going straight down, you're not skiing, you're falling, free fall. So when we have a vertical line, we say vertical line slope. Those are undefined. You don't have a slope. You're not skiing anymore. You're just falling. Moving on to question number 16. Number 16 says, find the slope of the line passing through the given points. So I have 2 points here. So we will learn that, or should have learned that our slope is equal to our change in y's over our change in x's. I like to label. I like to say, well, that's x1, y1, x2, y2. And it doesn't matter which ones are the x1s and y1, x2, y2, as long as the 1s are together and the 2s are together. Alright, so just using that. Right, I apologize, I'm not sure where we left off. My iPad warned me that my battery was dying, so I had to re-plug in. So I'm not sure where we left off. So I'm just going to pick this back up again. But slope is equal to my change in y's over my change in x's. Alright, and I've already labeled, I like to do that, x1, y1, x2, y2, and it doesn't matter which ones are the 1s and 2s as long as they're together. Alright, and just plug it in. I get negative 13 minus negative 1, so it's the same thing as plus 1. And negative 9 minus negative 6, same thing as plus 6. So that gives you negative 12 over negative 3, and a negative divided by negative is positive. So the slope of this line that contains these 2 points, m, is equal to 4. So there's question number 16. Moving on to question number 18, we're supposed to find the slope of a line that goes through these 2 points. And so again, we can say, well, this is equal to my change in y's over my change in x's. And you can label x1, y1, x2, y2. Now notice the y2, x2 and y2, that's the origin, 0, 0. So that's going to make it kind of easy to figure out. It's negative 4 minus 0, and it's negative 6 minus 0, which is just negative 4 over negative 6. When you reduce that, it's just equal to 2/3. So the slope on number 18, m, is equal to 2/3. Moving on to question number 20. 20, find the slope that goes through these 2 ordered pairs. So again, m is equal to my change in y's over my change in x's. And I like to label so I don't mess up on my substituting. And so m is equal to 4 minus 4, and that's 7 minus 11. 4 minus 4 is 0. And this is negative 4, but 0 divided by anything is 0. So the slope of this line is 0. And this is a horizontal line. Now, sometimes you can see things before actually working them out, if you're paying really close attention, you can see that your y values are the same. Alright, that simply means that it goes through the y-axis at 4. Alright, and it stays 4, so it stays flat, so that's a horizontal line, so you didn't really have to work this one out, but if you didn't see that and recognize it, that's okay. Moving on to question number 22. 22 says, state the x and y intercepts and the slope of each equation, and then graph the equation. So let's find the x and y intercepts first. In order to do that, we let the y be 0 to find the x-intercept. So 2x is equal to 6. Divide both sides by 2. So x is equal to 3. So my x-intercept is 3, 0. So notice this thing is 1, 2, 3. It crosses right there at 3, 0. Now, for my y-intercept, I let my x be 0. So 2 times 0 plus y equals 6. So this is simply just y equals 6. So my y-intercept is 0, 6. So 1, 2, 3, 4, 5, 6. So I know it crosses the y-axis at 0, 6. So there's my graph. Okay. Just use those 2 points, and if this is not a super straight line, forgive me. Alright, and then to find the slope, you have 2 points, so you could use y2 minus y1 over x2 minus x1, or I just like, if I have the graph, just to count, rise over run. Alright, so I like to try to always run right, so I'm going to start at this top point, although it doesn't matter. And I'm going to go down 1, 2, 3, 4, 5, 6. I'm going to go down 6, and over 1, 2, 3. So I went down 6, and I ran 3, so then my slope is m is equal to negative 2. So I have my x-intercept, my y-intercept, and the slope of the line. Moving on to question number 24. Question 24, I'm also supposed to find the x and y-intercepts, and then the slope of the equation and graph. So I'm going to find the x-intercept first. So when I do that, I'll let the y be 0. I get this. Solving for x, 0 divided by anything is 0. So 0 is equal to x. So I know that my x-intercept is 0, 0. Now if my x-intercept is 0, 0, where it crosses the x-axis, the origin, it's also the same for my y-intercept. So I don't really have to plug in 0 for the x to figure out my y. It's going to be 0 again. Alright, and then to find the slope of the line, well, in order to find the slope, I need at least one more point to graph. So I remember the slope-intercept form of a line is y equals mx plus b. Alright, so that's my slope. So if I went down 3, because slope is equal to rise over run. So if I go down 3, 1, 2, 3, and run 1, then that's the same thing as negative 3, which is my slope. And so then, here's my graph. Sorry, that was not a very straight line. And so my slope then, m, is equal to negative 3. That was kind of given to me in the equation when I first started. So my x and y intercept are both 0, 0. If you want to put it down twice, you can. Alright, and then your slope is m is equal to negative 3. Moving on to question number 26, find the x and y intercept. So I'm going to find the x-intercept by letting y be 0. So I have 4x minus 2 is equal to 0. Add 2 to both sides. So I get 4x is equal to 2, divide by 4. X is equal to 1/2. So I know my x-intercept is 1/2, 0. So right there, so it crosses the x-axis. The y-intercept is going to be 4 times 0 minus y minus 2 equals 0. It might just be easier to take the y to the other side. So negative 2 is equal to y. So my y-intercept is 0, negative 2. So 1, 2, so go down to 2, put a point. And this is a very steep line. Right? And then to find the slope, you can simply count. So from here, go up 2, and to the right, a half. So slope is equal to rise over run. I'm in trouble spelling. So m is equal to, I went up 2, and I went over 1/2. We wouldn't leave it as a complex fraction, so we would simply say, alright, this is 2 divided by 1/2, or we would say that's 2 times 2 over 1, which is 4. So my slope on this line is 4, which is very steep, and you can see it's positive because as you go from left to right, it goes up, so it's a positive slope. So there are my answers for question number 26. Moving on to question number 28, we are supposed to graph each equation using its slope and y-intercept. So I want to put it in this form, y equals mx plus b. Pretty easy to graph once you have that. If I notice, it already is in that form. Alright, so this value right here, that's my b, so if I want to label these, I can. You don't have to. But my slope is 1, and my b is -1, so that means it crosses at 0, -1. And then from there, I rise 1 and run 1. Always make your slope a fraction. So you can think of 1 as 1 over 1. So rise 1, run 1. And your graph looks something like that for question number 28. Moving on to question number 30. Supposed to graph this using its slope and y-intercept. So y is equal to mx plus b. Again, I know my m is 3/4, and I know my b is 3, so it crosses the y-axis at 0, 3, and then from there I rise 3, so 1, 2, 3, and run 4. 1, 2, 3, 4. Alright, and then try to graph the line. You probably would want to use a straight edge, something, but I don't have one right now, so your line looks something like that. Y equals 3/4 x plus 3. Moving on to question number 32, again graphing this using your slope and y-intercept. So this is the form. Now this one's not solved for y, so I need to solve this one for y, so I need to divide everything by 2. So that's 1/2 x plus 1/2 is equal to y. So my slope then is 1/2, and my y-intercept is 0, 1/2. So it crosses right there at 0, 1/2, and then go down 1. Or this is rise over run. So down 1, and over 2. 1, 2. Oops, I'm sorry. I shouldn't have went down. That's a positive 1. Should go up 1 and over 2. And then connect. And when I saw that I was going to have a negative slope, I looked and I was like, well, my slope's positive. It can't be going down. So I realized really quickly, because I know positive slopes are going up, left to right. When you have negative slopes, they go down, left to right. So when I was about to graph this, I saw I was going to have a negative slope. But you can't have that because I had a positive 1/2. So I quickly saw that and recovered. Alright. Moving on to question number 34, we're supposed to graph each line, label the x and y intercept, and state the slope. Alright, so this one right here, I need to graph the line. So I don't have this one on my grid. A lot of the times you just have to create your own. Alright, it's already in y equals mx plus b form. My m is the number in front of x, this is 1. My b is, well, 0. So it crosses the origin. And from there, I'm going to go up 1, over 1. So the graph looks like that. And it also says state the x and y intercepts and the slope. Well, I've already stated the slope. My slope is 1. And since it crossed the origin, my x and y intercepts are 0, 0. So you can label it twice if you want to. My x-intercept is 0, 0. My y-intercept is 0, 0. And my slope is 1. That's what question number 34 looks like. Moving on to question number 36. Again, I have to graph this, and I don't have this on a grid, but that's okay. You can make your own. If you don't have graph paper, a lot of times you have to anyways. And this one right here is x equals negative 3x. You can't really solve this one for y because there's no y there. When you're just given an x value, x equals something, that's always a vertical line. So everywhere negative 3, 0 is a point, negative 3, 1, negative 3, negative 1, negative 3, 2, negative 3, negative 2. And you can kind of see what's going to happen here. This is going to be a vertical line at negative 3 because all my x values are always negative 3. Doesn't matter what my y is, but my x is always negative 3. Now, when you have this, you say, well, what is your x-intercept? Well, the x-intercept is negative 3, 0. Say, well, where's my y-intercept? Well, these two lines are parallel, so there is no y-intercept. I'm going to abbreviate. No y-intercept, because it's parallel to the y-axis. And then the next question is, what's the slope? Well, there is no such thing as a slope on a vertical line. Again, think of it as skiing. You're not skiing anymore, you're falling. So that's an undefined slope. So there's the answers for question number 36. And the last one that we're going to do in here today, on this section, is problem number 38. And we're going to graph the line, so I like to put it in this form, y equals mx plus b. To me, it's the easiest thing in the world to graph. So I'm going to say, alright, well, this is going to be 4y is equal to negative 3x plus 10, divide by 4. And so y is equal to negative 3/4 x plus 5 halves when you reduce. So my m is negative 3 over 4, so that's my slope. And I know my y-intercept is 0, 5 halves. Alright, now that's enough to graph, but they also ask for the x-intercept as well. So to find the x-intercept, let the y be 0. So 3x is equal to 10. So x is just simply 10/3. So my x-intercept is 10 over 3, 0. Alright, and then graph our line. You can use those points if you want to, or you can use, it crosses at 5 halves, which is essentially 2 1/2. Alright, so this is 1, this is 2, this is 3, 2 1/2 right there. And then I could go down 3 over 4, because that's my slope. So down 3, 1, 2, 1, 2, 3, and then over 4. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Alright? And it's a little bit before negative 1. And if you draw a straight line through those 2 points, you'll have your graph. And you can notice that it's supposed to cross the x-axis at about 3 1/3. And so if you're doing this on a grid and you have straight lines and stuff, you can see that right here it should cross at 3 1/3, a little bit past 3. Alright, so again, if you're doing this on a grid and using a straight edge, like you probably should, you could see that. Alright, this is how you do question number 38.